Software testing is inevitable and considered an essential activity for software quality assurance. Conventionally, software testing is considered a manual process where a human tester performs a series of tests on a system. The development of new tools and emerging software engineering models has changed the way software is developed and tested. Modern software development follows the agile model, where features are added over time, bugs will be reported often during the development phase, and test engineers run various types of testing, such as regression and integration test cycles to ensure software quality. Eventually, fully functional software is released for the end users. This ever-evolving software development requires continuous testing, also known as regression testing. Newly added features require new test cases for evaluation, and in order to ensure maximum coverage, the whole test suite should be executed again and again to minimize the risk of letting a bug slip through the tester's eyes.
This makes regression testing inefficient as it requires more manpower and time to complete. For software companies, manpower directly translates to their annual budgets. According to a technology survey for a mid-sized company, testing alone costs around €719,000 per year.
In order to optimize regression strategy, software industry employed continuous integration practices and tools to reduce the time and manpower. This attempt proved successful in reducing the manpower, but regression time remained a problem because even with built automation, the whole test suite must be executed again, sometimes even multiple times, to test the new features and existing functionality. This makes regression test automation a vicious cycle. But every cloud has a silver lining.
Our team took an innovative approach to leverage the historical data being produced by test automation tools and applied more machine learning techniques to devise a dynamic test case selection and prioritization method.
We process test case history data with the help of an association rule mining algorithm named FP growth. This gives us association metrics like support and confidence between failed and passed test cases. The test cases, along with their association metrics, are then fed to a reinforcement learning agent, which processes the test cases one by one and learns to give a higher priority to those tests that are more likely to fail and thus reveal a fault in the system under test. But the work does not end here. Once the tests are executed, those new results are fed back to the agent along with the reward in the form of state-reward pairs. This way, the agent can incrementally learn to rank the test cases more precisely and adapt to the evolving test suite in the CI context.
Unlike existing techniques, which creates a fixed test schedule before the actual testing starts, our approach is dynamic, where tests are prioritized on the fly while they are being executed. In this way, information collected from already executed tests can be used to schedule the pending ones.
We aim to reduce regression testing time to 50% of the total available time for running a test suite within a CI cycle. This will not only expedite the developer feedback cycle in agile development, but will also save significant amount of money to software organizations around the globe.
This is our effort to bridge the gap between data science and software engineering by building a data-intensive intelligent testing system.